Hello! Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a developer advocate at Tanzu by Broadcom. So every week here on Cloud Native Live, we bring new presenters to showcase how to work with cloud native technologies. So we'll build things, we'll break things, and we'll answer your questions. Today we're here with Pun Jiang. He's going to talk to us about how to enable developer self-service with Seal, Walrus, and OpenTofu. I'm so excited. So this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So please don't add anything to the chat that's going to be in violation of the Code of Conduct. Basically, just be respectful to the other chatters, to the presenters, and to me. Please, and thank you. I have no doubt that you will. Friends who are joining us live, please do say hello in the chat. I love how this is a global community and we're having a global experience right now. So please say hello and where you're from. And also, those in the chat, if you have questions as the presentation is going, please do ask those questions in the moment, and we'll take a break from the presentation and we'll have a conversation and we'll answer your question as we go. So that's going to be super fun. And with that, I'm going to hand it over to Pun Jiang for today's presentation. Hi, Pun.
Okay. So thank you, Whitney, for the warmly introduction. Good morning and maybe good evening to everyone. And this is Peng from CO.io. And I'm very excited to have this opportunity in Cloud Native live stream and introduce how to enable developer self-service with Seal Walrus and OpenTofu. Okay,
Cool.
So let's start. So first, a quick introduction about Seal, our company, and myself. So Seal is a startup company founded in year 2022 with core team members from Rancher Labs, so which is a cloud native company who has developed a container management platform called Rancher. Okay, and our team members are experienced in open source cloud computing and DevOps. So in Seal, we want to develop open source platform engineering projects. And about myself, I'm the co-founder of Seal, and I'm an engineer with infrastructure background, and I have been working in IT industry for maybe should be 19 years. Yeah. So before Seal, I worked in SUSE and Rancher Labs, Citrix, and Microsoft. And my Twitter and X ID is pengjiang80. Yeah, so probably because I just read and never post, so it was suspended several months ago. So I'm still struggling to get it back. Okay. Okay. So about OpenTofu. So I think most of you should already know OpenTofu. So, but I will just use one slide to quickly introduce it. So OpenTofu is a community-driven open source fork of Terraform since HashiCorp changed their Terraform license last year. So now OpenTofu is a Linux Foundation project, and the first GA version 1.6.0 was released in this month. So in January 10th this year. So it just has some minor difference between OpenTofu and Terraform currently. So OpenTofu has some new module testing feature. It has an updated S3 backend, and it also has its own OpenTofu provider and module registry now, and it contains some other enhancements. But frankly speaking, currently at this point, because OpenTofu is just an open source fork for Terraform, so it also has some limitations, just as Terraform. So the first one is environment management. So if you're a Terraform user, you know that there is always a debate whether you should use workspace to manage different environments or not. So in general, workspace is not a good idea. So probably you need to use maybe multiple folders or something like this to manage different environments. The second one is composable modules and workspace. So it's also a question to whether you should use a mono module or multiple module to handle some complicated scenarios. For example, if you want to create a Kubernetes cluster with OpenTofu, then you need to create VPC, you need to create a subnet or something like this. Then probably you need to create a root module. Then you need to create some other sub modules and to complete this task. But it's a very complicated and big module. Then it will cause a big blast radius. So, and it's hard to maintain. And also, it will cause a long runtime, and also it will be very difficult to handle drift detection, to handle drift, something like this. And the third one is multi-modules orchestration. So you know that in Terraform or OpenTofu, there is no stack or application concept. So which means that if you want to manage multiple modules, you need to find your own solution and to manage them together. And there is no official solution in OpenTofu. So this is from the operator perspective. So from the developer perspective, there are also some limitations. So the first one is that as an IAC tool, infrastructure as code, so there are too many operation-related things in OpenTofu and its modules. So HCL, HashiCorp configuration language, is good. It's quite simple for a developer, but HCL itself doesn't work. We need to use different providers and different modules to manage infrastructure. And each of them contains a lot of things related to infrastructure, which may not be related to our developers. And these infrastructure-related things require additional knowledge and may add cognitive load to our developers. That's not a good thing. The second one is multi-cloud portability. So developers love containers because it provides portability. You can build one container image and run it everywhere. So, but for OpenTofu modules, normally they are specific for a certain cloud or certain infrastructure. So if you use OpenTofu modules directly in your application definition, then most likely you will need to update the definition for each environment independently if they're using different infrastructure. And the third one is infrastructure and resource management without application view. This is the same thing as in previous slides. So as an IAC tool, OpenTofu itself just focus on infrastructure management, and there is no application view. So what developers really care is the application. They just want to have the infrastructure dependencies ready as quick as possible and use them in the application system, but they don't want to manage them. That's why we want to create a solution to enable developers to do self-service and manage the infrastructure more efficiently. So from our point of view, we think there are 3 key points to achieve this. The first one is application view, which means that you need to manage the infrastructure resource in certain applications instead of manage them independently out of your application system. The second one is reduce complexity, which means that there are some developers who have very good infrastructure knowledge, but there are more developers who don't know infrastructure very well, and they don't want to, or they don't have time to learn it. So we shouldn't expose the infrastructure concepts directly to the developers if we want to achieve developer self-service. And actually, the complexity is not just for infrastructure only, and it also includes the complexity of Kubernetes. So the third one is cross-platform portability. So container is great because it provides portability. Once you have your container image, you can run your application almost everywhere. But in the real world, the entire cloud-native application system is more than just Kubernetes, right? You need a database, you need MySQL, you need a load balancer, and other things. Most of them are running outside of your Kubernetes cluster, and normally they are different in different platforms. So it will be great if we can use a single definition to describe our application system and run it anywhere. So this is what we want to achieve through Walrus. So Walrus is a fully open source application platform based on IAC tools such as OpenTofu, Terraform, and we will expand to support more IAC tools in the future. And we want to enable developer self-service through Walrus. Okay. here is a architecture diagram for Walrus. So Walrus is based on Kubernetes. So it has some core services. So the first one is a resource manager. So resource manager will be responsible to synchronize your template registry and to manage your resource and to compose it as an application. So resource manager is also responsible to call the developer to do the real infrastructure provisioning task. So for each run, it will create a Kubernetes pod, and for each pod, it's actually a developer deployer. So currently, we support OpenTofu and Terraform as two deployers, and we will support more IAC tools and deployers in the future. And the second one is the operator. So since OpenTofu is just an IAC tool, and the main responsibility for it is just for resource provisioning. So if you want to do some other management related tasks, such as start or stop the resource, or maybe do some check the logs, or go to the container share or something like this, you need some other tools to achieve this. So that's why we have an operator component. And also we have a built-in workflow engine, which is based on Argo workflow. And all the data in Walrus currently, we don't store it in etcd. We store it in a PostgreSQL database. So this is a high-level architecture of Walrus, and I will demo it later. Okay, this slide is the core concepts and the scenario, core scenario of Walrus. So in the left side is a Walrus file. So Walrus file is for developer. So it's similar with the Docker Compose file. In this slide, you can see there is a sample file, so which is an WordPress application. So it contains two resources. So the first one is a WordPress database, and you only need to define the type as MySQL. And the second one is a WordPress service. So the type is container service. And for this resource, you can define some attributes, such as the container image and the port you want to expose. And also it contains some environment variables which refer to the output of your WordPress database. For example, you create a database, then that database will have a database host address and the database password and the database username. Then you can use this output as the input of your WordPress service and use it. Okay. So with this single Walrus file, we can deploy it to different platforms. So for example, if you're a developer and you have your laptop with Docker engine installed, then you can use this Walrus file to create a Walrus deployment totally based on Docker. And if there is a test environment or formal development environment in your company, which is based on Kubernetes, then you can use this Walrus file to define and deploy your application as Kubernetes workloads and Helm charts. And if there is a production environment, for example, based on AWS, then you can use this Walrus file to deploy your application in your EKS cluster, and you can provision the database as a RDS database. And if you also have maybe a disaster recovery environment in your Google Cloud, and you can even run the container service as a Google Cloud Run, which is something like a serverless or fast service. And you can also use the database as a Google Cloud Circuit. So how to achieve this is based on the resource definition, so which is in the right side. So resource definition is actually a group of matching rules and some template configurations and parameters. So it's configured by the operator to define the rule to confirm which template and what parameters should be used to provision your infrastructure resource based on certain criteria or different filtering rules. So next I will do the demo to show how could we achieve this through Walrus and OpenTofu. Okay.
Will you go back? I think maybe you're about to demo what my question is, but does like the developer take that file and apply it to different environments, and it, depending on which environment you apply to, it creates it? Is that the idea? It's a single file, but it can be applied to lots of different places for the same result. Okay, cool. Thank you.
Okay. So, okay, let's start. So the demo will be based on this slide. So first, we will start from the local environment. So you can download the Walrus client through through our GitHub repo. So currently, we haven't published it to Homebrew or some other platform yet. So you can only download it from our release page. Okay.
Will you make make it bigger, please?
Okay.
Thank you. Yes, awesome. Thank you.
Currently, we support Linux and macOS, and Windows support will coming soon. Okay. Okay, in my client, I already have a Walrus client installed, and okay, and also have a Docker desktop installed. Okay, so now I can use the Walrus local install command. Or maybe I need to. That may be clear. Okay, Walrus local install command will install a Walrus Docker extension to your Docker desktop. Okay, it will take just maybe 1 or 2 minutes.
During that time, we can say hello to some folks in chats. We have a hello from Nigeria, hello from Romania, from Dubai, from Germany. So cool. Yeah.
Cool.
Are we back up? Okay, cool.
And good evening and to everyone. Okay. Okay, now it's already installed. So if we switch back to Docker desktop, we will see a Walrus extension here. So it's a little bit small. I'm not sure. Okay.
Wonderful. Thank you.
Okay, so we can go back to the terminal. Okay. Now, in my laptop, I already have a application, a Walrus file defined. So just as the slide showed, it's a WordPress application, and it contains a WordPress database and a WordPress service. So now I will try to deploy this application to my local desktop. So I will use Walrus apply.
We have a question. If if you're doing it locally, do you need Docker desktop?
Yeah, currently,
Okay.
for local environment, it depends on Docker desktop because it will install a Docker desktop extension. Actually, it's also a Walrus server. I will show it later. So it's actually a local Walrus server, but if you will call your local Docker engine and to create the Docker containers. Okay.
Excellent.
Okay, so I will use --wait, then it will. So now I have 2 resources created, and the first one is the DB, and second one is the WordPress. Okay, since I used the --wait parameter, so it will return once the resource are deployed. Okay, preparing and deploying.
So we have another question. Kushal says CNCF is really interesting and that they want to contribute to this project, whether they mean OpenTofu or Walrus Seal Walrus. I don't know. But how's a good way to contribute for folks who want to contribute?
Yeah, so you can go to our GitHub project, and we have documentation about how to contribute to this project. We have the API document and the architecture design document. So any contribution, feedback, or issue is really appreciated. Okay.
Awesome. Thank you.
Okay. Okay.
If we're still waiting, I'll say hello to someone in Springfield, Missouri. And we also have Geneva, Switzerland. Super cool.
Oh, Switzerland. Okay.
Welcome.
Okay. Okay, so this data set is ready. Now I can use the Walrus resource list to see the resources deployed. Okay, now I have 2 resources deployed. So the first one, and it also contains the endpoint, which is returned by Walrus. So I can use open command to access this address. Okay. Oh, okay. I have my WordPress ready. So how it works, uh, so actually, if I use Docker command and use Docker ps, so I will see 4 containers running in my local desktop. So normally, you would expect that there's only 2 containers, but there are 4 containers. It's because we used a special OpenTofu module to create a post container, which is similar as Kubernetes. Then we can ensure that it's compatible with Kubernetes deployment in the future. In case you want to create multiple containers in your Kubernetes deployment, you can also use it in your local Docker deployment. Okay, that's the case. So if you want to see the local Walrus deployment, you can just access the local address.
We have a question.
Yeah.
Is Walrus compatible with Rancher Desktop?
Currently not. We may support it in the future. Yeah. Okay.
Cool. Thank you.
Okay. So if you access the local host and the 7443 port, then you will see the local Walrus server deployed. So it will contain the default project and the local environment.
Can we make it bigger, please?
Resources. Okay.
Thank you.
Okay. And how it works, so it's based on the built-in resource definition. So if you go to the resource definitions, you will see there is a built-in MySQL definition. So the type is MySQL. Yeah.
I'm sorry, I can't see it very well. Will you make it bigger?
Okay.
Thank you. Awesome.
Okay. So the name is Docker and the type as MySQL. So if the environment matches this matching rule, then we will use the Docker MySQL OpenTofu template to deploy the container for you. Okay. So now let's go to the second scenario. Okay. So we have this definition, Walrus file, and we can also deploy it to a Kubernetes cluster. So technically, you can use your local Walrus to manage Kubernetes or even your public cloud. But in a formal scenario or in a real case, you need to independent Walrus server to do this. So let me switch to my demo environment. So could you see it?
Mm-hmm. And where's this running?
Yeah, it's running in this server is in AWS. Okay.
Okay.
Okay, this is a server with Docker engine installed. So as mentioned, so Walrus is based on Kubernetes. So you can install it in a Kubernetes cluster, or you can use a single server installation. So you can follow the steps in our official document. And
we have a question from the chat. What operations can I perform on applications running on Kubernetes?
Yeah, I will demo it later, so you can start or stop the resource which actually create and delete the Kubernetes deployment, and you can connect to the container share, and you can see the log files of your container. Yeah.
Cool.
Okay. Okay. Let me go back to my server. So I can use a single server install mode too. Okay. So I can use this docker run command to start a Walrus container, and which is a single node installation. So we can do this because in the Walrus server image we have embedded a K3s server. So if it's a single node installation, it will use the local K3s as a task engine and run it. Okay. Oh, sorry. Oh, sorry. It's the wrong server. Sorry. It's this one, and that one is a K3s server.
Okay, so we're on AWS on a K3s server.
Yeah.
And where you're going to run it locally on AWS.
Yeah, this one I have two servers, and this one is a Walrus server. I will deploy Walrus, and this one is a K3s server, which I will connect it by Walrus later to deploy your Kubernetes application. Okay.
Okay.
Okay. Now I have the container running, and I will use Docker logs to see the log file, and it may take 2 or 3 minutes to be ready. Then we can access the Walrus UI.
Okay. That's good because we have questions rolling in. Kid has a question. Later he redacted it, but I personally am curious because I don't know a lot about Terraform, honestly. So where's the state stored in Terraform and OpenTofu?
Actually, it's a good question. So
I think so
if
too.
you're using Terraform or OpenTofu CLI client, so actually it's just the state file is stored in your local folder.
Okay.
Okay. But in Walrus, currently we store the state file in the PostgreSQL database we used.
Okay. You talked about that when you showed the architecture diagram. Yeah. We have another question. It'd be great to know how Walrus is different from Backstage and how can I develop custom features and plugins on Walrus?
Yeah, it's a good question. So Backstage is actually an internal developer portal. So I think it's a portal. It has many plugins. So you can integrate your code repo, your CI/CD system, or your Kubernetes cluster, or other platform to Backstage, and your developer can use Backstage as a single portal to do almost everything here. And for Walrus is an application platform. So we may develop a Backstage plugin in the future, so you can use Walrus through Backstage to manage your application and your environment.
Excellent.
Okay.
And then if you're using Walrus, do you still need OpenTofu?
Yeah, I will show it later. So OpenTofu is a deployer. So it's a runner of Walrus. So we can switch from Terraform to OpenTofu, and we plan to support more IAC tools in the future. Okay.
Awesome. And those are the questions. Thanks everyone for your questions.
Okay, I think the server is ready. So let me try to access this server. So I already have it's Walrus-CNL Cloud Native Live and .cio.net. Okay, so since it's a self, okay. Since it's a first installation, I need to get the bootstrap password through this command. Okay.
Will you move the window so we can see your cursor from behind your name? I can't figure out how to. Yeah. Well, like you can have the server window open, but can you see the stream view? Basically, your name tag is blocking.
Yeah. I know.
Okay. Cool. Okay.
Okay. Let me change the window here.
Yeah. Thank you.
It'll be better.
Yes.
Okay. That will be better.
Yes.
Okay. See. Okay, now I have the Bootstrap admin password, and I can go back to the first login. And then I need to configure the password. Okay, now the Walrus server is ready. And
excellent.
Okay, the first thing you should do, since today we are talking about OpenTofu, so I will change the deployer image from Terraform to OpenTofu. Okay.
We make it bigger.
Yeah. Bigger.
Thank you.
Okay.
Awesome. Yes.
Okay. Yeah. So by default, it's a Terraform deployer, which is an old version because the the license limitation of HashiCorp. So let me change it to OpenTofu. IO OpenTofu and okay. Okay, and go back to okay. And since I will need to use a Walrus client in the demo later, so I need to generate API key and to configure my Walrus client. Okay, CNL demo and okay, go to my client. I will use Walrus login to configure my server. Walrus.cnl.cio.net and my token. And since it's a self-signed certificate, I will set it as insecure. Then the default project and the default local environment. Okay. And since I can see the management comment, it means that the client has been configured successfully and I can use it. So now what I need to do is I will create a connector. So from the operations tab. So the operations tab is actually for the operators. So the operators can configure connectors to connect to your infrastructure here. And the operators can also configure the catalogs and templates here. And the most important part is the resource definitions. So let me create the connector first. So the connector here is actually the Terraform provider or the OpenTofu provider. So for example, I create a K3s dev, and I need to choose an applicable environment type, which means confirms whether this connector can be used in which type of environment. For currently we have 3 built-in types defined, which is development, staging, and production. So let me choose the development environment. And I already have a K3s server ready here. This is my K3s server. So I will configure the kubeconfig file. Okay. Now I have a Kubernetes cluster ready, so I can create an environment and bind this connector to the environment. Okay, let me create a connector. I create a development environment here, and add connector, I can choose the K3s connector here. Okay, now I have a new development environment. Then I can go back to my terminal and try to deploy the application to this Kubernetes cluster. Okay, I can also use.
And so this is the exact same file you use to deploy locally.
It's exactly the same file, and you can see.
Cool.
You can just use cat. It's quite simple. So it's exactly the same file. Okay. Then I will use Walrus apply chef.yaml, and then I will use the -e parameter to specify the environment. So I will deploy it to the dev environment, and I will use the reach comment. Okay. So
excellent. We have a couple of questions. Would it now be a good time for that?
Yeah.
Cool. How does Walrus compare to Terramate? It's similar in that it abstracts application stacks.
Yeah, personally, I'm not familiar with Terramate, and although I know it, but I didn't spend a lot of time to know the concept. I think the common part is that both of us have some maybe stack or application concept to do this, but I don't think Terramate has a abstraction about resource definition. So it means in Walrus, for a developer, you don't need to understand and know the technical details for the underlying infrastructure. For example, just now I want to create a database. I just need to create a resource and to set the type is MySQL. I don't need to know whether I should use a module for AWS or a module for GCP or a module for Azure. So
Mm-hmm.
as I know, Termate is something like IAC management tool. So it's most likely for operators, but not for developers. But for Walrus, we want to reduce the complexity and make some abstraction, not just the application system or the stack. We also
Mm-hmm.
want to reduce or remove the complexity of infrastructure and Kubernetes. So I think this is the difference. But yeah, I will take more time to research Termate to confirm if this is correct. But yeah. Okay.
Excellent. And who, speaking of personas, like which persona is meant to set up the dev environment, like set up the Walrus server and do the connector and all those steps you've done previously to applying the YAML? Is that meant for an operator or are the developer supposed to do
Yeah,
those
so
steps?
actually, because I'm using an admin account, so I'm doing the things at both sides. So
Okay.
creating the connector and the template is actually the task performed by the operator, and apply the VARS file to deploy the application is actually the self-service for the developer. Okay, because
Uh
I'm using a single account and I only have one person, so I'm
huh.
just so to simulate two roles in this scenario. Okay.
Excellent. And then I'm skipping ahead a little bit to stay on topic with TerraMate. But is TerraMate a hosted solution? Do you know?
Oh, I don't know. I think yeah, because Termite is all. They also have some open source tools. I think they have a hosted solution.
Okay.
Okay.
And then back to the state. Are there any thoughts on how the state would remain reliable in the case of pod disruptions?
Uh, yes, because in my demo, I just use a single node installation, so it will use an embedded PostgreSQL server. But in your
Mm,
real production deployment, you can use an external database server. So
mm.
it will not affect if the virus pod is not available. Okay.
Excellent. And there's one more question. Does this support Terra Grunt? And can this be used in a GitOps mode? You did mention GitOps in your architecture diagram, I noticed.
Yeah,
Yeah.
that's a good question. So for the first one, currently we don't support TerraGrant, but we will evaluate it later, maybe in the future, because TerraGrant is a enhancement for Terraform, right? So it's also an IAC definitional tool, so we may support it in the future. And for GitOps, currently in this version, we don't support it, but we will support GitOps based on Walrus file in next release, which is Walrus 0.6, and we will release it in March before the KubeCon Europe.
Exciting.
Okay.
Awesome. Thanks again, everyone, for the great questions.
Okay, let's continue. So now I have the development environment and I have my application deployed as a Kubernetes workload and Helm chart. So as you can see, so the WordPress database is actually a Helm chart. You can see the
Hum.
subcomponents contains Helm release and it
We
contains Kubernetes pod. And for the WordPress resource, it's actually a Kubernetes deployment. So it contains service deployment and the pod. So through Walrus UI, you can, just see the logs of your container
will
pod,
will
and
you
you
make
can,
it bigger, please?
okay,
Thank you.
is it?
Awesome. Yes.
Yeah.
Thank you.
And you can also access the
Awesome.
container terminal through Walrus
Huh.
UI. And also we have a feature called dependency graph. So it will show the relationship. Yeah, maybe I need to smaller. So it will show you the resource in this environment and its subcomponents. So I can go to full screen and show subcomponents. Then it will show you the sub-resource actually. So it's called sub-resource in Terraform or OpenTofu. But in Walrus, since we call the top level as the resource, so we change the name to components. Okay, so you will be able to see the subcomponents of your application. Okay, and you will be able to see the relationship between them, whether it's composition or it's dependency or it's a realization. Okay. Okay. Let's go back. Now the next one is So how about if I want to deploy my application to a real staging or production environment? I don't want to use a containerized database. I want to use RDS. So let's go to demo this.
We have a couple questions while you're
Yeah.
in between demos, perhaps. Where are the deployers running? Are they running in pods, and are they configurable?
Yeah, it's running in Kubernetes pods, as mentioned just now. So yeah, we can do some basic configuration currently, but we didn't expose too much configuration parameters outside. So yeah, it's a good idea. So maybe you can describe your requirements or idea in our GitHub issue, and we will check if we can support it in later release. Okay.
Awesome. And one more. Can Walrus also deploy the actual Kubernetes clusters themselves through OpenTofu?
Yeah, definitely. Because OpenTofu is an IAC tool, so you can use OpenTofu module to deploy a Kubernetes cluster. And we also have the plan to, in the future, for example, you can use Walrus to deploy a Kubernetes cluster, or you can deploy a EKS cluster, or a GKE cluster, or AKE cluster. AKS cluster, and automatically we will configure Kubernetes cluster connector to that Kubernetes cluster, and then you can use it. Okay, let's continue. Okay, to use the public cloud, I need to configure a public cloud connector. So I will configure AWS Tokyo and dev. Okay, and staging, and I need to input the access key. And secret key, and for the region, I will set as Tokyo. Okay, now I have two connectors, and I need more connectors for different environments. So to save time, I will use Walrus client to create the connector. Okay, I will create so it's almost the same parameter as a user web UI. So you define the category, the type, the applicable environment type, and something like this. Then I create K3 staging as a connector for staging environment, and I will create another K3 production, and it will be used for the production environment. Okay. Then I will create another two AWS connectors. Oh, sorry. Okay. Environment type production. And purity. Okay. Okay, it's done. So let's go back to the web UI. Now I have 5 connectors, and I have 2 additional Kubernetes clusters for staging and for production, and I have 2 AWS connectors for staging and production. So what I need to do next is to create another 2 environments, the staging environment and the production environment. So I will use staging connector for K3s and AWS Tokyo. Oh, the name is dev. Oh, sorry, I think I aimed the wrong name, but doesn't matter. And then I create the production connector. And okay. Now I have the environment. What I need to do next is, as an operator, I need to define the resource definitions to let the developers to use this type of resource. So what I need to do is create another resource definition called AWS MySQL, and the type is MySQL, and I can define different matching rules. So the first one is a staging matching rule, and I can define different selectors to do the filtering. So first one is environment type, and I would like to apply this rule to staging environment. And second one is maybe environment label. So I will use a label to confirm that this environment has a AWS connector connected configured, so it can use AWS modules to deploy an RDS database. Okay, so okay, let me do it. So for each connector has different cloud providers configured. Walrus will automatically configure some system labels to that environment. For example, you have an AWS connector, then Walrus will automatically configure the walrus.co.io slash provider dash AWS label to that environment and configure that label as true. So I can use this label as a filter to confirm that this environment is available to use AWS template. So I can choose the AWS template. And since it's a staging environment, so I want to change some default settings. For example, I want to use a smaller database instance and maybe smaller database size. And I need to configure the VPC ID, which is mandatory for RDS database. Okay, now it's for, okay, I want to add another matching rule for the production environment, maybe for PRD, and it's almost the same. I need to filter the environment type and add an environment label filter to ensure that that environment has AWS connector configured. It's true. And still use AWS RDS.
We have a couple of questions. Is now a good time?
Yep.
Are there other connectors besides GCP and AWS?
Yeah, actually, you can add any OpenTofu or Terraform connector as a custom connector. So I will show it later. Okay.
Excellent.
So in my demo, I also include the GCP demo. Although it's not formally supported yet, but I can use it. Okay.
And then when we have time, I have another question, but there's no hurry.
Okay, let me complete the definition first. Okay.
Sounds good.
Okay. For this one, I will keep the resource class as the default, which is a T3 medium. And maybe I want to change the database size to a bigger one. And also, I need to fix the VPC. Okay, now I have the resource definition for staging and production environment for AWS. So let's try to use the same Walrus file and try to create it. Walrus apply /f demo. I have a staging environment. Okay, and I have a production environment. Okay, let's go back to the web UI to see. Okay, so Walrus will also handle the resource dependencies for you. So which means it means that if a resource A depends on resource B, Walrus will try to create resource B first, and resource A will be in the queue, and until the resource B is ready, it will be created. Okay, so let's go to see the first one, the staging. We can see the log file. Oh, sorry, it's too big. Okay, so too many log files. Okay, should be ready. Okay, so first you can see that it's using OpenTofu, the latest version, and it's trying to create an AWS database. Okay, we can also verify it through AWS CLI. So we can use AWS describe DB instances. Okay. So I have a staging database creating, and the class is what I have configured is a T2 micro, and the storage is 20, and I have another database creating. Let me see. It's not started yet. Let me. Okay, let me see the production environment. Let me check the connector. Oh, let me see. Production type. Let me see. I think I may configure the matching rule incorrectly, so it breaks something. Things always breaking demo.
We promised up top we would break some things, so I'm glad you kept me true to my word.
Okay. Let me check let me delete this first and try to recreate it.
We have quite a few questions building up when you're ready. Yeah,
Okay.
live demos are fun.
Let me check the resource definition first. Projection and Walrus true arm type projection. AWS RDS MySQL and MySQL. Purity provider true. Okay. Okay. Let me try to create it. Production provider AWS true. AWS ideas. Basic T3 medium. Advanced should be fine. Let me try to deploy it again. Okay, so let's go to the questions. Okay.
Excellent. One thing I was wondering this myself. What existing software is Walrus most similar to?
I'm not sure. Have you ever heard quite a new project called Radius, which is developed by Microsoft Error team?
Okay,
And
I'm not
I think
familiar.
it's open sourced maybe October last year.
Okay.
Okay, so I think they're different, but the concept is quite similar. So in Radius, so it's also an application platform, and in Radius, it also based on resource, and it contains it has a concept called recipe. So resource recipe. So recipe is something similar to resource definition. So which means that for developers, they don't need to care about the technical details and the implementation details of an infrastructure resource, and you just need to use it. And the operators will be able to define the recipe to define how to provision the resource through this recipe. So it's quite similar. So the difference is that Radius is based on Bicep and Terraform. So because Bicep is a IC language by error, and the second difference is that Radius has they they have some built-in resource types, so you cannot create your own type currently. So, but in Walrus, you can define your own type. You can define any custom type as you want. Okay. Yeah, but yeah, it's quite we know Radius almost I think it's in October. So they just open sourced it and contributed to CNCF, and we found it's quite similar. The concept is quite similar. Yeah, and for others, Walrus it may be similar to Kubevela. It's
Cuvella.
also
Okay.
yeah, Kubevela,
Mm-hmm.
but the application module is different. So in Kubevela, it's based on some components, and the
Mm-hmm.
components is actually the the basic of an application. So in
Mm-hmm.
Kubevela, there is no abstraction of infrastructure. They just split the configuration parts between components and trace. So in Kubevela, if you want to configure some parameters which may be related to operators, you need to define them in trace instead of define them in component itself. And so for the most similar to, I think it should be Radius. Okay.
Thanks. And then how can we better hide the complexity with Walrus? As an infrastructure dev, I only want to expose what's necessary for my app devs to do their work. I think most of what you've shown today is for an infrastructure dev or is for an operator. The app dev piece is just applying that same YAML file and changing your environment variable, like your environment to which one you want to deploy to, correct?
Yeah. So, yeah, what Walrus to do is trying to, just expose the required complexity or required parameters to your developers.
Mm-hmm.
So, yeah, maybe I can show more information okay.
Yeah.
So since it's creating the AWS database, so we can
Uh-huh.
go back to the basic configuration for the operators. So here is the catalog. So catalog is actually a group of templates or modules of OpenTofu or Terraform. So we have a built-in catalog which contains some templates developed by SEAL. But you can also add your own catalog, or you can also import a community catalog. For example, you can just import the AWS Terraform modules. Let me try to Google it. And, Terraform AWS modules. Yeah. Okay. So this is a GitHub organization for Terraform AWS modules. So you can just import it. Okay. AWS catalog. The Walrus will try to synchronize all these modules to local Walrus server, and then you can use them in your Walrus server. So I will show you the special things Walrus can do. Okay, let me add another catalog, which is a Walrus demo catalog. The source is okay. So it may take some time for.
Great. We have some questions. Well, we have Ken's statement that I feel like needs addressing. That Ken feels like they've heard Walrus isn't for application developers, it's for platform engineers. But the whole title of your talk even makes me think that you're trying to show that it's for application
Yeah.
developers.
So
Yeah.
yeah, actually, it's for platform engineers to build your internal developer platform, and which will serve your developers. Okay.
Beautiful. That's a great way
Yeah.
to put it. Is Walrus free to use or does it need a license?
Yeah, it's free. It's a fully open source, and it's based on Apache license, so you can use it for free.
Excellent. And are there any RBAC options available for Walrus?
Yeah, currently we have both RBAC and ABAC, but it's still in development. So we have 3 building roles, and you can have a general user, manager, and administrator, and they have different permissions for different platforms. So you can click to see the, I think you can see the user, for example, user.
And we're running out of time today, so maybe you
Yeah.
can pick one more thing to feature. Maybe you want to show the catalog that got imported.
Yeah. Okay.
Yeah.
Let me go to the catalog. Okay. Okay. So now this catalog has already synchronized some modules. I think we have more modules. Okay. And this is a AWS module, Terraform or OpenTofu module. And from this template, we have a UI schema. So UI schema is used to define how the module can be exposed or displayed to your developers or to your users, for example. So you can get more information regarding UI schema. So you can use some open API schema parameters to define how this UI will be displayed. So we also extend some additional features such as hidden, immutable, or show if. So you can control how the template will be displayed to your end users. So you can just modify this UI schema and you can do the preview and then you can use it. So you don't need to change any code or something like this, just to modify the UI schema. So the UI schema can also be used in resource definition. So as I showed just now, currently I have a AWS resource definition for the RDS database. And the default UI schema is just like this. And it contains the basic configuration and advanced configuration, right? So if I just want to hide the technical details for the end user, so for example, when I try to create a database from MySQL database, and currently I can see this user interface, and I think it's too complicated, and I want to remove some parameters and hide some technical details, then I can use the UI schema. So currently I have another already configured UI schema already is modified. Okay, I can just use this UI schema and replace my definition. Okay, and remove the old one and new one, then preview. Then it's quite simple. So it only contains 4 parameters. So the database engine version is a immutable, is a read-only parameter. So it's configured as 8.0. So users only need to input the username, database name, and the password to create the database. So it's quite simple. So you can customize the UI and you can control how you want to show your template or your resource definition to your end users through the UI schema. Okay.
Fabulous. So we're up over the hour now, so it's time to say goodbye. Is there anything for people who want to try this out and get their hands dirty? What do you recommend that they do? There we go.
Yeah. And the last slide. And so we're a sponsor for KubeCon Europe. And so if you will also join this, you can stop by our booth at number B31.
Nice. Okay. I'll stop and say hello. And then the GitHub link I put back on the screen, so you can also start there would be a good, if you're not going to KubeCon, that's probably a good way to learn more about the project. Yeah. Thank you so much, everyone, for joining us today. I appreciate you. It's been an especially good chat. Thank you, Punjong, for teaching us about enabling developer self-service with Seal, Walrus, and OpenTofu. Thank you, everyone in the chat. Thank you for those of you who watch the recordings. And here at Cloud Native Live, we bring you the latest Cloud Native code on Tuesdays and Wednesdays. So that means we're doing this again tomorrow. Tomorrow, we're going to talk about Linkerd. So join us then if you like at the same time, same bat channel. So thanks again. See you soon. Goodbye.